While people usually talk about chatbots, AI tools, and new apps, the real competition is happening much deeper in the technology stack inside data centers, inside servers, and inside the tiny but extremely powerful processors that run artificial intelligence. At the center of this competition are two massive tech players, Nvidia and Google. Both companies are racing to control one of the most important parts of modern AI, the chips that actually make it work. To understand why this matters, we need to look at how AI runs in the first place. When an AI model like ChatGPT or Gemini answers a question, it does not happen magically. Huge amounts of data are processed through complex calculations. These calculations require very powerful processors. Traditional computer chips, known as CPUs, were never designed for this kind of work. That is where AI chips come in. These chips are designed to perform thousands of calculations at the same time. This makes them perfect for training and running large AI models, and for years, Nvidia has dominated this space. Nvidia originally became famous for building graphics cards used in gaming computers. These graphics processors, called GPUs, turned out to be extremely good at handling the parallel calculations needed for machine learning. Over time, researchers and tech companies realized GPUs were perfect for training artificial intelligence models. As a result, Nvidia slowly became the backbone of the AI industry. Today, most of the major AI systems in the world rely on Nvidia chips. Companies like Microsoft, Amazon, Meta, and many others run massive clusters of Nvidia GPUs in their data centers. The demand has become so high that some companies have had to wait months just to receive shipments. Nvidia's most powerful AI chips, like the H100s, are used to train large language models that power many of the AI tools people are using today. Because of this demand, Nvidia has become one of the most valuable companies in the world. Its data center business has grown rapidly, and many analysts believe AI computing will drive technology for the next decade. On the other side, instead of depending completely on Nvidia hardware, Google started designing its own AI chips. These processors are called TPUs, which stands for Tensor Processing Units. The first TPU was introduced in 2016, but Google had been working on the idea long before that. Unlike general-purpose GPUs, TPUs were designed specifically for machine learning workloads. They are built to run Google's own AI frameworks efficiently, especially TensorFlow, which Google developed for training AI models. The idea was simple. If AI was going to become central to Google's products' search, translation, photos, ads, and cloud services, then Google needed full control over the hardware running those systems. Since then, Google has continued improving its TPU designs. The company has released several generations of these chips, each one becoming more powerful and more efficient. The latest versions are used not only for Google's internal services, but also for customers using Google Cloud. This is where the competition with Nvidia becomes more direct. Nvidia sells GPUs to almost every major tech company. Google, on the other hand, offers its own AI chips through its cloud platform. That means companies building AI models can choose between Nvidia GPUs or Google's TPUs. Nvidia GPUs are extremely flexible. They support many AI frameworks and tools, which makes them easier for developers to use. Nvidia has also spent years building a large ecosystem of software, including CUDA, which allows engineers to optimize their models for Nvidia hardware. Because of this, many AI developers are already comfortable working with Nvidia systems. Google's TPUs, however, can be very efficient for certain types of machine learning tasks. Since Google designs both the hardware and much of the software that runs on it, the company can optimize performance more tightly. This integration sometimes allows TPUs to train large models using less power and fewer resources. Another key difference is strategy. Nvidia focuses on building the best chips and selling them to everyone. Google focuses on building chips that strengthen its own ecosystem and cloud services. This difference shapes how the competition plays out. Nvidia benefits when more companies build AI systems because they all need hardware. Google's advantage appears when those companies decide to run their AI workloads on Google Cloud instead of competing platforms. Major tech companies are beginning to design their own AI chips as well. Amazon has its Trainium and Inferentia processors. Microsoft is developing its own AI hardware. Meta is also exploring custom chips. All of this suggests that the future of AI may depend less on general-purpose hardware and more on specialized processors designed specifically for machine learning.